In today's class, we'll be solving these questions on radio wave. As we all know that radio wave is an example of electromagnetic wave. What other examples of electromagnetic wave you know? Just drop it in the comments. Apart from radio wave, tell me one other examples or two other examples or three. If you can list up to three that you know that is also examples of electromagnetic wave apart from this radio wave, you can drop that in the comments. So we'll be solving these questions on radio wave. Now let's go on. The wavelength of signals from a radio transmitter is given to be 1500 meter, and the frequency is given to be what? 200 kilohertz. Okay. What is the wavelength? What is the wavelength for a transmitter operating at a frequency of what? 1000 kilohertz. Now, if it takes 1500 wavelengths to operate at 200 kilohertz, that is frequency, to operate at the frequency of 200 kilohertz, what will be the wavelength that will operate at a frequency of what? 1000 kilohertz. So that is what we'll be calculating in this video. We can see the following options given before us. So all what we need to take note is we need to get a formula that shows the relationship between wavelength and frequency for us to be able to determine this second wavelength. Okay, so first thing we need to do is to state out our parameters given in these questions. Now we're given the first wavelength to be 1500, just as you can see here, and we're given the frequency, the first frequency, to be 200, as you can see here. Then the second wavelength is what we are asked to calculate. Now the second wavelength is not given, while the second frequency is given to be this, and as you can see it here too. So what we need is that we need a formula that relates wavelength and frequency together. That a formula that relates wavelengths, you know, this wavelength, this lambda is wavelengths, a formula that relates wavelength and frequency together. So, but we have to take note of something, that a radio wave are also electromagnetic wave. Let's take note of that. They travel with the same velocity as what? As light. They travel with the same velocity as the speed of light. Here, you know the formula we use to calculate velocity of light, it shows the relationship between wavelength and frequency. The formula we use to calculate the velocity of light shows the relationship between wavelength and frequency. So far, this radio wave also travel with the same speed as speed of light. Therefore, we can use the same formula for this radio wave. And what is that formula? The formula says V is equals to F lambda. That is, V is equals to frequency times wavelength. Now, in this class, we're given. Now, what we do is that we don't have any much concern about velocity because we're not given velocity and we are not asked to calculate any velocity. So what we need in this video is just only the relationship between this and this. That is frequency times lambda. That is the only thing we need in this class. Okay. Now, if you check the question, you will see that we have two different frequencies. This is the first one to be F1 and this is the second one to be F2. So looking at this equation, we can be able to derive our formula we need to calculate the second wavelength. So what is just the only thing we need? We can say, okay, take this one to be F1 lambda 1 equals to F2 lambda 2. That is just it. So far we have gotten the relationship between frequency and lambda. Then we can proceed by saying what? By saying this. That is, we can also write it as this, that, you know, velocity is equals to what? Frequency 1 times lambda 1. That is the first frequency times the first wavelength equals to what? Second frequency times second wavelength. It's still the same thing. Third frequency times third wavelength, like that. Okay, but as I've said, that we don't need the velocity in this class. We are not asked to calculate velocities and no parameter is given for velocity. So we only need the relationship between this and this. So we only bring out this. That is the only thing we need in this class. And we have it to be what? To be this. Take note of that. We have it to be this. Okay? So now, what is the next thing? I will need to substitute the parameters given. These are f1 times lambda 1, that is the first wavelength, times, okay, equals to f2, that is second frequency, which is 1000, times the wavelength, which is the second wavelength, is not given. That is what we are calculating. That's what you are asked to calculate. Okay, so substituting the parameters given in the question, we have it to be this. We have it to be this. Okay, now if you see that here is frequency, here is also frequency. You can see the frequency here with the units, and you can see the frequency here too with the units. So lambda is like lambda wavelength is just like a distance, so it has the same unit as distance. Okay, now this unit here, we cancel this unit here, so I'll be left with what? Meter. I'll be left with meter here. So now what I will do is that I will multiply, already you know that this, we cancel this. Okay, so I will just multiply 200 times 1500 here, and then divide our result by 1000. 200 times 1500, then divide our result by 1000 to get the value of the second wavelength, and that will give us what? Yeah, that will give us 300,000 meter. And if I divide 300,000 meter by 1000, I will have the value of our lambda to be what? To be this. That is the value of our lambda. That is 300 meter. That is the value of our wavelength is equal to 300 meter. And the correct answer to that is option B. Please, if you find this video helpful, consider to like the video, consider to comment, consider to share with your friends, and subscribe. Turn on the notification button, that anytime we upload new video, you can always get notified. Thank you. See you in my next video.